So now welcome back. So in this video we want to talk about linear equations, pair of linear equations in two variables. So this is one of those things that are also important in mathematics. So we want to talk about pair of linear equations in two variables. So basically the first thing that we have to cover here, I have some notes over here and we'll go through them one by one. So first of all, basically what a pair of linear equations is that, for example, let's say you have 2x plus 3y. You have 2x plus 3y is equal to 5, for example, and x minus 2y is equal to x minus 2y, for example, minus 3 is equal to 0. And the general form of these linear equations in two variables is of course this way, meaning that you would, in the general form of this equation would be 2x plus 3y minus 5 is equal to 0, and the general form of this is already in general form, so x minus 2y minus 3 is equal to 0. So this is a pair of linear equations in two variables x and y, for example. So basically what these pairs of linear equations in two variables, what they do for you is that they give you some way to, in order to figure out some situations, like, for example, let's say that you have a number, I don't know, 36, for example, and you have some number 36, and let's say that I ask you a question. There is a two-digit number. There is a two-digit number, and the first digit is equal to half of the second digit, and also the sum of the two digits is equal to 9. Okay. So this is the information that I have given you, and of course let's pretend that you don't know that the number is 36, and so if you know that you have a two-digit number, the first digit is equal to half of the second digit, and so the sum of the two digits is equal to 9. So you can, based on the information that you have here, you can write two equations, meaning that you can take the first digit as take it as x, and the second digit you can take it as y, and now you know that the first digit is equal to half of the second digit. So the first digit x is equal to half of the second digit y, and the sum of the two digits is equal to 9. That means that x plus y is equal to 9. And now you have a pair of linear equations in two variables. Okay, so now what you can do is that you can actually solve this pair of linear equations and see what the digits are, meaning that I can take, for example, if I call this equation number 1, if I call this equation number 2, I can substitute 1 in 2, and instead of x I can write 1/2 y. So equation number 2 becomes 1/2 y plus y is equal to 9. So that's 1/2 y plus 2/2 y is equal to 9. So 3/2 y is equal to 9. So y is equal to 9 divided by 3/2, or 9 times 2/3, and that's equal to 6. So if y is equal to 6, then you can use this over here. So y is equal to 6. Now you can use it over here, for example. So number 1 gives x is equal to 1/2 y. X is equal to 1/2 y. So your x is equal to 1/2 6. So 1/2 times 6 is equal to 3. So your x is equal to 3. So your x is equal to 3, y is equal to 6. And here I took the first digit as x, probably. Okay, so I took the first digit as x and the second digit as y, and your x was equal to 3, or y was equal to 6, and so your number becomes 36. So that way, supposing that you didn't know that the number was 36, you can solve this. You can, in this situation, you can figure out what the two digits are, and well, basically solve the problem. So that's basically what this whole thing is all about, and so this was basically we call this way of solving the problem, we call it the algebraic method of solving the problem. There is one more way to do that, and that is basically you can also do the graph of the two equations. So x is equal to 1/2 y. That means that if you make some changes to this equation, x is equal to 1/2 y, that gives 1/2 y minus x is equal to 0, or let me write it this way. So you would have multiply both sides of this equation by 2, you would get 2x is equal to y, so y is equal to 2x. This way you can graph the equation easily. So then y is equal to 2x would be something like this. So if you go to, for example, if you go to desmos.com, you could, so f of x, for example, or y is equal to 2x, and you see that you'll have a straight line that goes through the origin. And then moreover, the other equation was this thing over here, x plus y is equal to 9. So y is equal to minus x plus 9. So minus x plus 9 is So f of x is equal to minus x plus 9. And you see that you have this, you have another line over here, another straight line. And you see that the x coordinate there's a point over here where the two lines will intersect, and that is basically this point over here. And the coordinates of this point are 3, 6. That means that your x is equal to 3 and your y is equal to 6. And that way you can also solve the problem, see where your solution is. So that's basically how, I mean, what a pair of linear equations in two variable is, and how you can solve it. Of course, there are many other ways to some other algebraic ways to solve these equations. There are some there's also the graphical mode where you graph both the equations, and then see where those two lines, for example, intersect or something like that. But the whole story is basically this simple thing. And now what we have here is some information regarding these linear equations, pairs of linear equations in two variables. We will go through some definitions, and we will go over some different cases of these linear equations, and then we will do a couple of exercises so that you can use them as a tool when you're doing mathematics. So that's basically what this whole thing is all about. So that's basically the whole story here. Okay, so basically now that basically we have seen that example, and for example one of the equations that we had was, for example, 2x plus 3y minus 5, for example, was equal to 0. So basically a linear equation in two variables is an equation that can be written as ax plus by plus c is equal to 0, where basically a, b, and c belong to the set of real numbers. They are real numbers, and what's important here is that basically a and b are not both zero. Meaning that they cannot be zero at the same time. One of them can be zero. You would still have a linear equation. Well, you could say in two variables in which one of your variables is, for example, 0. But if you have two of them, if both of them are 0, then you will essentially have c is equal to 0, and that would basically be a horizontal line and not a slanted line. So a and b are not both 0, and this condition is usually written mathematically as a squared plus b squared is not equal to 0, meaning that not both a and b can be 0 at the same time. Okay, so and then basically a solution of a linear equation in two variables is a pair of values is a pair of values x and y, where basically is a pair of values x and y that satisfy both of those equations. So you have basically something like a1 x plus b1y plus c1 is equal to 0, and you have a2x plus b2y plus c2 is equal to 0. And then you have the solution would be something like x and y, and this x and y is going to satisfy this equation and also this equation, and that's basically called the solution of this pair of linear equations in two variables. And what the solution actually means is that, for example, if you have 2x plus 3y minus 5 is equal to 0, if you have 2x plus 3y minus 5 is equal to 0, then you have basically, you can write it as 2x plus 3y is equal to 5. Now if you have the point 1 comma 1 as your solution, that means that your x is equal to 1 and your y is equal to 1. And if I set the right hand side of this equation would be, or the RHS would be 2 times 1 plus 3 times 1, and that's equal to 2 plus 3, which is equal to 5, which is equal to actually this is the left hand side, I'm sorry. So this is the LHS of this equation, would be 2 times 1 plus 3 times 1 is if you substitute at this point in the left hand side of the equation, and then you would get a 1, which is basically equal to the right hand side of the equation, and therefore you can say that 1 comma 1 is a solution of this equation number 1, because it satisfies it. Okay? What's important here is that basically if you have this equation over here, 2x plus 3y minus 5 is equal to 0, 2x plus 3y minus 5 is equal to 0, then you can write it as 3y is equal to minus 2x plus 5, and so y is equal to minus 2/3 x plus 5/3, okay? And of course, now if you set the point 1 comma 1, if you substitute it in this equation, you would get 1 is equal to negative 2/3 times 1 plus 5/3, and 1 is equal to negative 2/3 plus 5/3, and 5/3 minus 2/3 is equal to 3/3, so 1 is equal to 3/3. There's a question mark over here, and of course 1 is equal to 1. So basically you get some equation like this, and you see that this point 1 comma 1 is actually satisfying this equation. Now what this graphically means is that you have a you have this so if you write this as negative 2/3 x plus 5/3, so negative 2/3 x 2/3 x plus 5/3, you will get this point over here. You'll get this line over here, and you will see that, of course, any point on this line is a solution to the equation that represents this line. For example, if you take this point, any point on this line, you can see that I can just keep going along this line, and I'll get an innumerable number and an infinite number of points over here. So for example, you see this point over here, 2.5, comma 0. This is also going to be a solution to this equation, 2.5 comma 0. So basically 2.5 comma 0. So let me rewrite the equation over here. Y is equal to negative 2/3, actually 2/3 x plus 5/3, and the point was 2.5 comma 0. 2.5 I write it as 5/2 and comma 0. And if you substitute this point into this equation, you'll get 0 is equal to negative 2/3 times 5/2 plus 5/3, and that's equal to 2 and 2 you can cancel out, so you'll have negative 5/3 plus 5/3, and that's equal to 0, and these two will cancel out, and 0 is equal to 0. So you see that this point is also a solution and satisfies the equation. And any other point that you try here, for example 0 comma 1.667. So 1.0 comma, for example 0 comma 1.667. And this point is actually 667 is I think it's 2/3, if I'm not wrong. So 2/3 is equal to 0.6666 and so on and so forth, repeating, right? So what that means is that 1.667, and you know that this was actually this number has been rounded, and the number was actually 1.6 repeating. It just keeps going 6, 6, 6, 6, and so on and so forth. So if you want to write this number as a fraction, what you can do is that you know that this number is the same thing as 1 plus 0.66, actually 6 repeating, right? So 6 repeating would be 2/3, so that's 1 plus 2/3, and 1 plus 2/3 is the same thing as 3/3 plus 2/3, and that's the same thing as 5/3. So 5/3 is 1.6667. 5/3 is the same thing as 1.6 repeating. So I can write this point, I can actually write it as 0 comma 5/3. That's actually the same thing. Now, if you basically try this point as well, meaning that if you consider this equation over here, and if you put this point, substitute this point in this equation, you get 5/3 is equal to negative 2/3 times x, which is equal to 0, plus 5/3, and this is 0, so 5/3 is equal to 5/3, and that's actually also a solution. But there are some points over here that do not lie on this line. For example, this point over here. For example, 2 comma 2, right? This point over here, 2 comma 2, you see that it's not on the line. It doesn't lie on the line. If I tried that point over here in the equation algebraically, I would get, for example, let's say that the point is 2 comma 2, and if I substitute this point in this equation, I'll get 2 is equal to negative 2/3 times 2 plus 5/3, and 2 is equal to negative 4/3 plus 5/3, and 2 is equal to 5 minus 4 is equal to 1/3, which is actually not correct. It's not true. So what that means is that this point does not satisfy this equation, and graphically you can see that the point does not lie on the line either. So that's basically, and so you can say that and so you can say that this point is not a solution of this equation, but this point is a solution of this equation because it does satisfy the equation, and it does also basically lie on the line, on the graph of the equation. So what you can say is that any point that lies on this line, representing the equation, is actually a solution to the equation, and any point that is not on the line is not a solution to the equation representing this line. And as you can see, this line is actually a collection of an infinite number of solutions basically put together and being represented as a straight line. Okay, so basically you can say that every solution of the equation, so you can say that every solution of the equation is a point on the line representing it. Is a point on the line representing it. This is important. This is important. Every solution of the equation is a point on the line representing it. So that's all about that. Now, okay, so basically, one thing that you can say in order to have a general, in order to have this, to state this in a more general way, you can say that every solution, x comma y of a linear equation in two variables, which is basically usually, which is generally written as ax plus by plus c is equal to 0, corresponds to a point on the line representing it. Representing actually, it refers to the equation. Representing the equation and vice versa. So every solution xy of a linear equation in two variables, which is usually written in the form ax plus by plus c is equal to 0. So every such solution corresponds to a point on the line representing the equation, and vice versa, meaning that every point on the line does actually correspond to some solution xy of the linear equation in two variables. So and then now basically this is all about a linear equation in two variables, which is basically only, for example, ax plus by plus c is equal to 0. Now when it comes to a pair of linear equations in two variables, so a pair of linear equations in two variables is a set of such linear equations which in two variables, such basically you can imagine basically two of these equations. For example, let's say a1x plus b1y plus c1 is equal to 0, and then another linear equation like, for example, a2x plus b2y plus c2. So you have a set of linear equations in two variables, and these two are basically taken together, and both of these equations are representing or giving information about the exact same situation. Okay, so what that means is that the exact same situation, and they have the same two variables. Meaning that, for example, the variables over here in equation number 1 is x and y, and the variables here are also the same things x and y. Okay, so if you have two linear equations in two variables that are basically taken together, and they are basically giving us information about the exact same situation, and I'll tell you just in a minute what I mean by this second point over here, and they have the exact same two variables. That system is basically called a pair of linear equations in two variables. Okay, so and what I mean by the second point here is that representing or giving information about the exact same situation, you can imagine that the situation of the two numbers that we talked about in the beginning of this video, that there was a number, for example, 3 and 6, and then we said that, for example, the first number is half of the first digit is half of the second digit, which was, for example, represented by x is equal to 1/2 y, and then we said that the sum of the two digits was equal to 9, and that was represented by x plus y is equal to 9. And this is the situation that we had. We were trying to figure out what this number was. So, and these two basically equations, as you can see, are basically giving us information about the exact same situation, meaning that it's not like, for example, this equation number 1 is giving me some information about this number, and equation number 2 is giving me, for example, information about some other situation, some other number. Both are about the same number. So in that case, they are representing or giving information about the exact same situation. And based on that, basically, if you have these three basically you could call them, well, conditions, then in that case they are called a pair of linear equations in two variables. And that's the general form of a pair of linear equations in two variables x and y. And as we said before, a1, b1, b1, c1, a2, b2, c2 are all real numbers. Here. And in this equation number 1, a1 and b1 cannot be 0 at the same time. So we write this as since they cannot be 0 at the same time, so I write it as a1 squared plus b1 squared cannot be equal to 0, and also a2 and b2 cannot be 0 at the same time. So I write it as a2 squared plus b2 squared. It cannot be equal to 0. And that's basically the general form of a pair of linear equations in two variables. Okay, so the next thing that we the next thing that we have here is page number 3, somewhere over here. Now, you already know that basically a linear equation in two variables is actually the graphical representation of that is actually a straight line, meaning that if you have, for example, if you have a1x plus b1y plus c1 is equal to 0, as an example, for example, 2x plus 3y plus 5 is equal to 0, this is a straight line. And you know that if you have, and when it comes to a pair of linear equations, you would have a2x plus b2y plus c2 is equal to 0, and then you would have some other line, for example 3x plus 2y minus 3 is equal to 0, and then you will have some other line over here, and these two together will make a pair of linear equations in two variables. Okay, so, and you know that each of these linear equations is a straight line. So both of them taken together is going to be, for example, some situation like this where you have the xy plane over here, and then you will get some line over here and some line over here. Let's call this 1, let's call this, for example, 2, and for example this one would be 1, this one would be 2, and then there is a point over here that both of these lines are intersecting, and that point is going to be the solution of this system of equations. So you know that so now, but now you know that given two lines in a plane, if you have two lines in a plane, given two lines in a plane, you have the three, you basically, you can have you can have only three possibilities, meaning that number one, the two lines will intersect, intersect at some point, okay, or the two lines will not intersect, the two lines will not intersect, and that's basically meaning that they are parallel. And case 3 would be the two lines will be coincident. Coincident basically means that you have basically the exact same two lines, and we will see what that means with a couple of examples that we are going to have shortly. But for basically this case over here, that the two lines will intersect at some point, you will have, for example, some line like this and another line like this, and you will and the two lines are going to have some point of intersection, for example this point over here. Or if the two lines are parallel, you know how that happens. You have basically two lines over here, and then these two lines are parallel, and that's basically what happens in case number 2. In case number 3, the two lines will coincide, meaning that you have this line over here, and then the other line is the exact same thing. Of course, their algebraic representation might seem to be a different line. I mean, for example, you could have, for example, 2x plus 3y plus 5 is equal to 0, and then you could have another line, 4x plus 6y plus 10 is equal to 0, okay? And you see that they seem to be two different lines. But if you take this equation over here down here and divide everything by 2, you'll get 4x divided by 2 plus 6y divided by 2 plus 10 divided by 2 is equal to 0 divided by 2. And then what you will get is 2x plus 3y plus 5 is equal to 0, which is the exact same thing as this equation up here. So that means that these two lines are actually equivalent lines, and they will of course coincide. Now that we have basically have now that we've had a little bit of now that we've had a little bit of definition and general information over here, let me see what I can do next here. Okay, now I think I'm going to give you some typical situations. In the next video, I'm going to give you three typical situations. We'll talk about them, and then there are a few more basically parts to this that we will cover in the next video. So I'll see you in the next videos. Thank you.